Hello, I've had a question about number 15, and this is from part 1 in lesson 8. So we have the advertising sign. So here's our sign. It's hanging by a steel cable. So here's the cable, and then we have the rod, the steel rod that's holding the sign out from the wall. What do we have here? Wires attached to the building above the brace at an angle of 25 degrees as shown. The force of gravity on the sign is 850 newtons. Find the tension in the wire and the compression in the steel brace. So what I do recommend is kind of give yourself a picture of the vectors. And the point of interest is where the sign's hanging. So that is our point of interest. So I'm going to draw the point of interest right here. It says the sign's hanging, force going down at 850 newtons. Now that steel cable, if you think of it, if that's the cable, it's pulling to hold the sign up. So that means the vector is going to be heading in the same direction. And from a Z pattern, green pen here, we know that the angle with the y-axis will be the 25 degrees as well. And then the sign, let me erase some crazy stuff here. This vector right here, the steel rod is pushing to keep the sign out from the wall. So the vector is going to be drawn like that. So I have my tension vector, I have my compression vector. So there is our diagram of the vectors involved. Now you can do this one of two ways. You can do the algebraic method, or you can do the geometric method. So the geometric method, if you're going to do it that way, you need to convert these vectors into a closed triangle. The reason it's a closed triangle is because nothing's moving. So what I would do is I would draw my compression vector. So there's my compression vector, plus tension, plus my tension vector, and then sign vector, the mass. So let's just call it our force vector. We know that the angle is 25 degrees. And the nice thing with this is because the force vector and the compression vector at a 90-degree angle, this is an easy question to do geometrically because we can just use SOHCAHTOA. So we can say that the magnitude, and let's do compression first. So that would mean that here's my angle. So we have a hypotenuse, opposite, and adjacent. So that means that cos theta equals adjacent over the hypotenuse. Cos 25 equals the magnitude of our compression vector over magnitude of the tension. So that was not the right one to pick, since I want to solve. I know the opposite side, so I got to use opposite here. So let's go with we'll go sine theta equals opposite over hypotenuse. Sine 25 equals magnitude of our force over our magnitude of tension. Now we know the magnitude of the force, so rearranging this equation, magnitude of tension would equal magnitude of force over sine theta. And you can substitute these values in a lot earlier. I'm just kind of writing out the values, or keeping the original values there. So now we just got to calculate that out. My calculator tells me that it is 2011 newtons. Now I can do the compression one as well, and I'll use tan. So tan theta equals opposite over adjacent. So tan 25 equals the magnitude of my force over magnitude of the compression. Rearranging that, magnitude of compression, it's magnitude of force over tan theta. So that would be 850 divided by tan 25. And from that, divided by tan 25, I get 1,823 newtons, let's call it. All right, so there is how to do it geometrically. And if you're happy with the geometric process, if that's the one you prefer, you're probably done at this point. If you want to continue watching, I'll do it algebraically, just to show you what the algebraic version will look like. So that's the algebraic method uses that diagram right there. Okay? So we know the algebraic method, so start with tension, for example. Tension would be the magnitude of the tension, cos 25, and now I gotta be careful with the direction here. So it's negative x, positive y. So it's gonna be a negative in front, plus magnitude of the tension, sine 25j. Compression vector, magnitude of the compression, and I don't have to do sine or cos here. I mean, technically, it is cos of 0, all right, but cos of 0 is just 1. So I can just say compression in the eye plus 0j, because it has no vertical component. And finally, the force vector, there is no x component, minus 850j. And we know that the result of this, our resultant, is 0I plus 0j, because there's no motion and there's no movement. Now, if we look at the y component, so if I steal my y component here, we can see there's only one unknown. That is the tension. So that means I can take the y component. So I know that the magnitude of my tension, sine 25, minus 850 equals 0. So the magnitude of my tension, move the 850 to the other side, divide by sine 25, and you'll notice my original solution, the geometric method, we've gotten to the same location, just a different approach, so we'll get the same answer. And then we need to take the x component. I'm just going to kind of squeeze it in here so I can see the top before I scroll down. Negative of the magnitude of tension. So I'm looking at this column now. All right. Cos 25 plus magnitude of my compression will equal 0. So now I'll scroll down so I can finish that. So moving out to the other side, I would get magnitude of my compression equals magnitude of tension, cos 25. And we know from above, magnitude of tension, oops, if I know it, I'm going to replace it, 2011 cos 25. When you plug that in, that gives you 1,823 newtons. So there's the two methods, the algebraic method and the geometric. You only have to do one. Again, it's the one you're most comfortable with. But there's both, you can see both solutions, and both equal amount of time either way. All right, hopefully this answers your question. If you have any other questions, please let me know and I'll follow them up.